Okay, today we're doing a problem from page 195, and what we're going to do is we're going to graph a quadratic function and then analyze the pieces of it. So here we go. This is problem 3, and here it is. So we got the function x is equal to x squared minus 8x plus 12. All right, so since I would rather actually graph the function first, that's what we're going to do, because I think it makes it easier a little bit later on solving the rest of it. All right, so in order to actually graph this and make it convenient, we're going to complete the square, and then we'll graph the function from there. You put b over 2 squared, and you add that, and then subtract it so that you're actually adding nothing. And b in this case is 8. And then minus the same, whatever the same thing is. And I'm going to put those in once I solve it. So b is negative 8. So we got negative 8 divided by 2 squared. Well, that's 16. Add 16 and subtract 16. So in essence, this whole thing is 0, but in order to solve it, it makes it more convenient. All right, so now what we do next is we break this down, and we can say that x minus 4 squared plus 12 minus 16. See, what I did here is I took these and I broke it down a little bit. So I took x squared minus 8x plus 16. And then since this is a perfect square, this is the same thing as saying x minus 4 times x minus 4. You notice these are the equivalent. So that allows me to break this down a little more simply, or to write this a little more simply, and it makes it easier to graph in the long run. All right, so to graph this, I'm going to try something a little new here. I'm going to try to use a ruler on this tablet. Yeah, it worked pretty good. All right, so this one right here means that the function is shifted down 4, and then this one here means it's shifted right 4. All right, so our graph starts at negative 4, the vertex of our graph is at negative 4, and then it's shifted to, the graph is also shifted to the right 4, meaning our vertex is right here. And now to graph it the rest of the way, we can find 2 other points and kind of get what the general shape is going to be. And since we know it's a quadratic, or since this is a quadratic, we know it's a parabola of some sort. So let's see, if I plug a 2 into here, I get negative 2 squared minus 4 is 0. So if I put a 2 in, I get 0. And if I put a 6 in, I get 2 squared minus 4, which is also 0. See, so now we've got 3 points, and we already got kind of the basic shape of the graph. You know it's a parabola, so it does something like that. It kind of comes up like this and goes on, and this side kind of does the same thing. All right, so there we go. We've graphed it. So that makes the next parts a bit easier. Okay, so this is part D of the problem, the last part, but I did it first because I think it makes it a little bit easier. All right, part A asks for the vertex. All right, so you can either use the function negative b over 2a, and then f of negative b over 2a. And I'm going to do it both ways, but if we just look at the graph, we can see that the vertex is at 4, comma, negative 4. Okay, now I'm going to check it using the equation that we've got here. So b is negative 8, over 2, because a is 1, and this whole thing is negative. And then we've got f of a negative 8 over 2. All right, So this is 4, and then the function value for 4, if we plug that in, as you can see, this becomes 0 if you plug 4 in there. So you're left with -4. And as you can see, they check. They're the same. The next part, B, asks for the vertical line that is the axis of symmetry. So, axis of symmetry. What that really is the equation x equals negative b over 2a. In other words, this is the same thing as the x coordinate of your vertex. So this line is the vertical line that goes through your axis of symmetry. So we know that x is equal to 4. That's our axis of symmetry. Let me draw that on there. Okay, so there's one last part to this problem, and that is they're asking if the vertex is a maximum or minimum value. Well, by looking at the graph, we can see that this is a min value because the function is at its lowest point at the vertex. But if we want to do this the mathematical way, we can solve it using this method. It also allows us to double check. So here we go. So the coefficient of the x term with the highest power our x squared term, because this doesn't work in all cases, but for this equation it does, since it's a parabola. So the coefficient of the x squared term, a, is what will determine whether this is a minimum or a maximum value. So if you have an a value that is less than 0, that means that your function is opening downwards, meaning that all values that are plugged into the function other than the actual vertex, all values of x plugged into the function will give values less than the value of the vertex. So what this is effectively saying is that a less than 1 is equal to a parabola of the form of negative x squared, meaning it opens down. And as you can see, the vertex is the maximum value. So this is this means that the function's vertex is the maximum. And so for the other direction, a greater than 0, this says that the coefficient on the x squared term is positive, and that means that the function's in the form of x squared, meaning that the function opens upwards and that the vertex is at the lowest point. So it's a min. And so this also indicates that this is the minimum. So you really are looking at, when you look at your quadratic function, you're looking at this. And then you're looking at your a term to see, is this positive, or is this if this term is positive or negative? And depending on which that is, that'll determine whether the vertex is a maximum or a minimum. If it's less than 0, in other words negative, then it's a max, and then if it's greater than 0, then it's a minimum. And that's about it.